Hi there. Thank you for clicking on this video. This lesson is going to take us through the different forms that quadratic functions can take and how to move back and forth between those forms. Please give this video a thumbs up if you find it helpful, subscribe for more math content, and check out the practice set for this video and other videos on the channel. So there are three forms for quadratics, and we want to go through what those forms are and the advantages of each. So first off, we have standard form. This is y equals ax squared plus bx plus c, where a, b, and c are real numbers. And this form tells us the y-intercept, and it is the best form for operations, meaning if you have to add, subtract, multiply, or divide with your quadratic, you want it to be in standard form. Now, when I say it tells us the y-intercept, here's the deal with that. We know that on the coordinate plane, the y-intercept, wherever the y-intercept happens to be, has an x coordinate of 0. Whatever, like all those points there have an x coordinate of 0. So if you take your equation in standard form and you plug in x is equal to 0, okay, 0 squared is 0, and a time, well, it's all 0, and b times it's 0. And you can see very quickly that your y-intercept is going to be your c value. So wherever your x is 0, your y value is going to be the c. And so your c is the y-intercept. So if you want to know the y-intercept of your quadratic, standard form is going to show that to you because it's going to be your c value. The next form is something called vertex form, and that is a times x minus h all squared plus k. And the big advantage to that is it tells us the transformations in the vertex. Now, I have seen students tell me, like, I'll ask, what's the best form for showing vertex? And they'll tell me something other than vertex form. Okay, we're not trying to be sneaky or slick there. Vertex form is good because it shows you the vertex. And if you haven't checked out the lesson on transformations, do that, because we go through how that number right there tells us whether the parabola moves left or right. This number here tells us whether the parabola moves up or down. And so we are able to see those transformations, those slides. Okay, we could also see if the parabola is flipped over or if it's dilated or compressed. We can see what else is going on. But the big advantage to vertex form is it does tell you the left, right, up, down, and where the vertex is. And factored form is the one you see at the bottom. That's y equals a times x minus p times x minus q. And that one tells us the x-intercepts, and it tells us the solutions to the corresponding equation. So if you were trying to solve an equation, you would look for those x-intercepts. So here's what we mean by that. If you look at your x-intercepts, the coordinates of every x-intercept is where y is equal to 0. And so if we take our factored form and we plug in y is equal to 0, then we know that if we have three things multiplied together, like a, x minus p, and x minus q, and the product is 0, then either a is equal to 0, which is not possible. If a is equal to 0, then you don't have a quadratic. X minus p is equal to 0, and x minus q is equal to 0, and then you could add p to both sides and add q to both sides. And so we can see that, like, our x-intercepts would be like p0 and q0. So the p and the q would be the x-intercepts. And then again, if you were trying to solve the equation, this would be the form that would get you to those solutions. So each of these three forms has things that it does for us, things that it's good for. All right, now how do we move between the forms? So we can algebraically manipulate the functions to change their form. So if we've got it in standard form, but we need to put it in vertex form, or vertex form, we need to put it in standard form, factored, like, and so forth. There is no direct way to move between vertex and factored form. So there's no way you can just look at that and get to here, okay, without going through standard form. All right, so if you had to move between forms like that, you would take the vertex form, put it in standard form, and then go from standard form to factored form, and vice versa. If you're in factored form, you would multiply that together to get standard form, and then you would go from standard to vertex form. Hopefully I said all that correctly. I apologize if I switched words around. I've learned by going back and watching my videos how scarily I might say the wrong word because I'm staring at one word and saying another one. But now very few functions will be nice in both vertex and factored form. Now, to be fair, there's an infinite number of functions that will be, but comparatively they're a little hard to find, and that's because sometimes if your vertex is in a nice spot like the 0.34, your x-intercepts are going to be these really yucky numbers. It won't be a nice quadratic to factor. And if your x-intercepts are nice, it puts your vertex. Now, I can write problems where, yes, they all come out nicely, but usually we're kind of working in one or the other. Now, for the purpose of this lesson, we're going to keep the a value equal to 1. And that's because the process of going from standard into vertex form, we really want to have that a value equal to 1, but you can do these things with a equal to something else. The practice set is going to look at some problems where a is not equal to 1, so be sure to check that out. Always check out the practice set. It gives you a chance to apply what we did in this lesson, and a lot of times, like, new insight and instruction happens when we go over the problem, so don't neglect that. All right, now for factored into standard form and vice versa. So that funny symbol there is a back and forth arrow. This is covered extensively when you study factoring and multiplying. So when you do your study of quadratics and you go through the process of factoring and you go through the process of polynomial multiplication, you pretty much cover this. But here's just a quick review so we can go back and forth. If you have something in factored form and you want to go to standard form, you need to multiply those binomials. For a lot of students, you might use the FOIL method, first, outer, inner, last. Okay. I use in my classes the area model. So we would take x plus 2 and x minus 3, and essentially it is foiling. You just are putting it on the page differently. So just so you guys can see that, it's really the same thing. So like that's your first, so x times x is x squared. There's your outer, x times negative 3x is negative 3x. Here's your inner, 2 times x is 2x, and there's your last, 2 times negative 3 is negative 6. And if you look at that, it's exactly the same things, like the x squared and the negative 3. Just when you FOIL, they're laid out like in a line. If you use the area model, they'll be laid out in a box. And in both methods, your next step would be to simply combine the middle terms. Okay, so negative 3x plus 2x is negative 1x, or just negative x, and you do the same thing over there. So whichever method you like, I think the area model has advantages for other things, which you'll see later in this lesson when we go to go from standard into vertex form. So okay, now to go from standard into factored form, this you need to go through your process of factoring. And again, I use the area model for that. So I put in the x squared, I put in the 3, I look at my coefficients, 1 times 3 is 3, and then I factor this. Oh wow, look, it goes right back to the 1 and the 3 again. They need to add up to -4, so it'll be -1 and -3. So it'll be -1x and -3x in there. GCF factoring, so the greatest common factor between x squared and -1x is x. X times x is x squared, -1 times x is -1x, and -3 times x is -3x, and -1 times -3 is +3. Therefore, my factors are x minus 1 and x minus 3. Now, if you got lost in that, I have several videos on the channel. You want to look under either Quadratics or look under Algebra 1. And I think I have them saved under Algebra 2 as well, because it's one of those topics that spans different levels, but some very extensive instruction on factoring, as well as entire practice sets that really review the gamut of factoring. They're long videos, but they're going to take you through a lot of examples and practice. So be sure to check those out if you need that review. Right, now to go from vertex into standard form, this is also something that is covered fairly extensively in the other stuff that you cover. So you square the binomial, and I did put in there square the binomial using multiplication. You cannot distribute the squaring, so it does not go like x squared plus 9 in that. You do need to multiply that out. Now, if you're not sure what I mean by that, when you square something, it means to multiply it by itself. So that is x plus 3 times x plus 3. And then you can multiply that any way you want. So I'm going to use my area model. X times x is x squared. We have 3x, we have 3x, and we have 9. So we have x squared plus 6x plus 9, because the diagonal is going to combine. And then the second step there is to simplify, which is really just going to be that tail end piece there. So x squared plus 6x, 9 minus 5 is 4, and we have gone from vertex form into standard form. So square the binomial using your multiplication and then simplify, which is usually just adding or subtracting in whatever that last number is. Now here's where it gets more fun. To go from standard form to vertex form, this is the piece that's new. It's the piece that would be brand new, probably in Algebra 2. You might have an Algebra 1 teacher that covers it. I covered it in my Algebra 1 playlist, but with the knowledge that it's really kind of dancing around how we're not in Algebra 1 anymore. And hopefully I said that correctly, because now I second guess everything. Now this involves a process called completing the square. I want you to check out the video linked above to see this process modeled with algebra tiles. So this is something that we can make very concrete, very visual. So I'm going to go ahead and link that right here. All right. And make sure you go check that out and then come back and check out the steps. Okay, so hopefully you did that. You clicked on that. The link should appear in the description box. You can click over to that and then come back. Hopefully you did that. If you didn't, like, rewind the video, go do it. Now here are the steps summarized. Okay, we want that kind of algorithm. You're going to take your B value and divide that value by 2. And typically, you know, we can do this with odd numbers, but the arithmetic gets pretty awful. So typically we will keep that with like even ones. You're going to divide the B by 2 and then save that number. And then square the result from number 1. Whatever you get for your answer to number 1, square that in your next step. And then add and subtract the result from number 2 to the function. So you're going to add it in one place and subtract it somewhere else. And that actually corresponds to that 0 pair that we saw with the algebra tiles. So in the algebra tiles, we actually had to add 4, if you think back to that first example. And then we had to subtract 4. We had to bring in the +1 tiles and the -1 tiles together. Okay, we had 4 of them in that particular example. So you're adding and you're also subtracting. You just got to make sure that you visually do it in the right spot. factor the perfect square trinomial, and for that you're going to use the saved number from number 1. So I said save that number. That will save you from having to go through the factoring process. And then simplify. And I don't know what the electric company is doing, but they have been outside my window like every day. And now there's a guy in a bright orange vest tinkering with all our electric stuff out there. I don't know what's going on. All right, so here are 2 examples. And what I did was I literally copied the steps from the previous slide up here so you can kind of follow along with the steps. So first thing we do is we take our B value and we divide it by 2. So in this first one, my B value is 4. So I'm going to take 4, divide it by 2, and it says save that number, save that positive 2 there. We're going to use that number later. It saves us from the hassle of having to go through the factoring process. Square the result from number 1. So we're going to take that 2 and square it, okay? And that brings us back to the 4. And then step 3, add and subtract the result from number 2. So here's what that looks like. We're going to do x squared plus 4x, and then right in here is where I'm going to add the 4. Picture that as the square part, okay? We're adding on to that square part. And now we're also going to subtract that number. And just like we did on the visual with the tiles, we're going to kind of move that over to the right-hand side where we had all our collection of 1s over there. We're adding or subtracting from that collection of 1s. For the next step, it says, factor the perfect square trinomial. Now you're like, what do you mean the perfect square trinomial? Well, this piece right there, that's what we were doing. That's how we came up with this. And here's like the nice little shortcut. You can use that saved number from step 1. So back at step 1, when I said save that number, here's why. Because it'll just be x plus 2 all squared. So you don't have to go through the process of factoring by grouping or your area model or whatever, because it's going to be that plus 2. Okay, it's whatever you had to divide those rectangles into. And then -1 minus 4 is -5. And there we go. We have done standard form and moved it into vertex form like so. Let's do one more example. So take our B value, in this case -2, and we're going to divide that by 2, and we get -1, and we're going to save that number because that's the number that's going to come up in step 4. I mean, if you don't believe me, you can do it out, but like it's always going to be that number. Step 2, square the result. So -1 squared is +1. And then step 3, add and subtract that number. Okay. Now, is it possible that we could just like borrow, this is like the where we could just borrow the 1 out of the 5? Yes, which if you can do that without making a mistake, go for it. But for most of us, when we're doing this algebraically, we want to have some kind of pattern. So we're going to add it. And then we are also going to subtract it because we don't want to memorize different things to do. Usually, we don't want to memorize different things to do. Next step is to factor the perfect square trinomial, and that's going to be this part. In other words, put it into the perfect square now that you know what the perfect square is. And we can use our saved number. Remember, our saved number was that -1. So that'll be x minus 1 all squared, and then 5 minus 1 is 4. And again, if you want to go and click back over to the algebra tiles, like now that we've gone through it algebraically, go back, rewatch that. It's only about 6.5 minutes from beginning to end to see that and just reinforce what this process is. So we have once again gone from standard form into vertex form. And that's it. So don't forget to like and subscribe for more math help, comment below to engage, and check out the practice set. I'll try to make sure I link that below so that you can practice moving back and forth between these different forms. And I hope I see you in a future video.